So today's webinar is on our program called the SRA, our Safety Reliability Analysis. And it's talking, I want to introduce what it is, how we do it. We're going to give some examples and show how if you are already doing your engineering above and beyond, if you're already doing some of these wonderful things in the industry, how you can take credit for the things that you're doing well. So for those of you that do not know me yet, my name is Loren Stewart. I'm a CFSE here. I've been here for over 8 years now, and I help with a lot of our mechanical customers. I help them achieve certification, and I also do a lot of our exida Academy instructing. So I go and teach a bunch of our courses as well. For you, those of you that don't know exida, I see a couple people that I'm not familiar with. We are involved in the complete supply chain of functional safety. So anyway, if you're an OEM making the devices that need certified in this SRA, the whole way through to the end users who are using those devices in their plants, maintaining them, proof testing them, and doing their SIL calculations, we can help. We have tools, software, we have experts, training, consulting, certification, all sorts of things that can help you out. I like to say no matter where you are, where your products are going, where your customers are, we have somebody close by that can help you in functional safety, alarm management, and cybersecurity. And then final thing about exida, and then we'll get into why you're really here. I always like to tell all of my customers, no matter, always check to see what we have released and what our latest information is. We are constantly putting out their books. We are releasing white papers that you can download for free on our website, these free webinars, blogs, all sorts of information. If we are researching things, doing things, our processes, procedures, everything, we like to get that out there in the real world. We figure if we feel that we're doing the safest things, we want other people to be doing those safe things as well, to get that information out. So always check back on our webinars, our blogs, our white papers, and see what we're getting into in our research. You never know when it can really help you. But let's get into why you're here today. We're going to be talking about the SRA, the Safety Reliability Analysis. What the SRA is, some examples of it, how it's done, and how it can make you stand apart to your customers. What can it show to your customers that you really are going above and beyond? Throughout the webinar today, I'm not very good at stopping and taking questions. I get on a roll and just keep talking. However, at the end, if you have any questions, make sure you type them into the panel, and at the end, I'll take some time and answer any questions. But today, we're going to be talking about the SRA and the FMEDA process. The FMEDA process is really affected the SRA. The FMEDA is the Failure Mode Effects and Diagnostic Analysis. And that is where we analyze an individual device against all of the stresses thrown at that device and see if the strength can hold up to the stresses applied. From that FMEDA is where we can get those predictive analysis failure rates. And when we do typical FMEDAs, we are doing them under the assumption that it's a typical device using the standard or typical component database. And we know that sometimes that's not the case. Typical isn't where we always are. There could be cases of really, really bad, and there could be cases of really, really good. We're not going to focus on the bad this webinar. We're going to look at only the good. We know that some companies, some manufacturers, some engineers really do go above and beyond their typical engineering designs or typical engineering practices. And the SRA is going to be a deep dive analysis into what you did to go above and beyond. And we can then show that to your customers. So this really came up because while we're in the field, while we are talking to end users, while we're talking to manufacturers, we hear over and over again 4 key issues. First of all, that things that move at different times, fast or slow, have different failure rates. Absolutely. So we created a second database for dynamic or constantly moving components. Another thing that came up is that the same device, exact same make, manufacturer, everything, can go into different sites and behave differently. Absolutely. It depends on the site and how they are maintaining it, what they are doing. So we have different site application models and rates. The next complication we always come into play is that when you put final assemblies or put final elements together as an assembly, they don't always work how you think they are. Some people just pick a random valve, a random actuator, a random solenoid, throw them together and hope they work. Well, other people do a complete torque analysis. They design the mounting and coupling with FEA and not just scrap metal. So we have a program on that now too. And the fourth major complaint that thing that we see occurring is some design techniques and some companies are really doing better than others. They're going above and beyond. So if they're putting better products out there, they're going to see less failures return, less things come back, and they should have lower failure rates. So we are offering this SRA. We're going to do a detailed component level analysis to give credit for your high design strength or the better than typical engineering process that you went through. So that SRA, as I kind of already told you about, it's the safety reliability analysis. What is it? Well, it's that advanced component analysis. It's going to be that deep dive into what you did better. So the first thing we're going to do is say, well, why is your solenoid? Why is your valve? Why is your actuator better than your competitors? What did you do in your design to make you stand out? Those are the things that we're going to analyze in the SRA. Whether it is your design that you've changed, whether it is stress test reports, field failure data. We're going to look at all of this and combine it together and obtain a special or that lower failure rate for your device, depending on what was changed and why. As I said earlier, the exida FMEDA was done on that standard component database based on your typical engineering designs, which is wonderful and great for most and many manufacturers. It was designed so we could get not have to dive deep on every single component and do FMEDAs within an appropriate time frame and a better price frame. However, if it's something that you want to highlight and look into, we can do that deep dive on those certain components. If you want to showcase what you're doing, if you want to show that you have the lower failure rates, if it means something to your company, especially to your customers, they can use those lower failure rates in their SIL verification calculations. That could then affect their SIL calcs, which is a big deal to them. So now, if you're already doing the testing, if you're already doing the component, the materials analysis, if you're already doing this above and beyond, take credit for it and have some sort of proof to show to your customers in those being those lower failure rates. You've already designed a device that's either stronger or better or lasts longer than most. So tell us how you did it and take credit for all that hard work. I already mentioned how we do a FMEDA. We look at each individual component, every single one, each nut, bolt, screw, O-ring, everything. And we look at the strength of that component versus every stress that we can throw into it. We look at Possible stresses like environmental or process stresses, things like shock, vibration, humidity, temperature changes, stiction, corrosion, different movement, abrasive materials, all of that. And we see how your device stands up to it. In our detailed analysis in our SRA, we can then look at that spring or that O-ring or whatever it was to make your device better, faster, stronger, and then why it was better, and then look at all of these stresses thrown at it in that variation. We will look at it at a very specific design and a very specific application and environment and see what has changed. Typically, in a normal FMEDA, we use that typical component or standard component database. And at the end of that process, we are given a product failure rate, product failure mode, and diagnostic coverage. We're going to do the exact same process, but with the SRA, after the FMEDA, we're going then do that deep dive into those particular or those special components, whatever was above and beyond in your engineered practice to make your device special. In that, you're still going to have your product failure rate, your product failure mode, and diagnostic coverage, but now you're going to have a lower product failure rate. You're still going to know what product failure modes, the safe and dangerous, and the different variations, and you're still going to have your diagnostic coverage. But that could even be affected as well, depending on what you've changed in your design. This is our typical flow chart for certification, and through it, we do our gap analysis, our initial safety case, our FMEDA, our site audit, our final safety case, and then we send out our documents. But now we have our SRA involved, and that comes to play right after the FMEDA, as I talked about. We'll do our FMEDA as normal, and then do that deep dive into what makes you special, what makes you better than the others. And then we'll also look at that application review. We'll look at the specific stresses that can be applied in your device and see how your device stands up to those. And so I keep talking about if you do this, you could have lower failure rates. Well, how do we prove that? How do we know that's going to happen? So the science behind it, so this is a little bit nerdy of me. So the science behind it, where we come into and think of failures rates and failures going to be. Failures occur when your stress overcomes the strength of your device. So these are our typical stress strength curves. And under where the typical stress overcomes the typical strength, so this area, gray, under the curve, is where your failures are going to happen. And that's where we can do predictive analysis and come up with failure rates because of this area under the curve. And the FMEDA analysis lets us do this. However, if you're going to do an SRA, what does that mean? You're adding strength to the design. You are making it that better, faster, stronger device somehow. So that's going to shift your strength curve. So the stress curve is going to stay the same. However, now you have a lot less area under that curve because the strength has increased. So let's zoom in closer. Once again, your special technology, your special testing, whatever you've done to make this device better, to increase strength, will take from the area from under the curve from your typical design to that added strength design. And this is the area we are able to calculate a less failure rate and a better predictive analysis for you. So now, how is it done? Well, we go back to the standards, IEC 61508 and IEC 61511, and they say no matter what you do, no matter how good you do it, if you can't prove it through documentation, it wasn't done. So, no matter how wonderful you make your device, it doesn't matter if you don't document it. So, we need you to prove it to us. Show us how you've made it better, faster, stronger. Show us your calculations, show us your FEA, show us your testing, and prove it to us. Once we do that, we're going to go back to that FMEDA, tear it apart, and give you those lower failure rates that you deserve. So let's look at a few examples, some real life examples of how this can be applied and create lower failure rates. So the first one we have is a safety PLC. So they were having a problem with the case temperature. This was seeing case temperatures of a microcomputer at like 70 to 80 degrees C. And that's normal or typical for these cases. So experts say that failure rates will drop significantly if these parts operate at lower temperatures. I've heard a general rule of thumb that they can be cut in half every 10 degrees or so. So what the engineers did for this module, they designed it to almost have a thermal short circuit between the processor case and this massive heat sink. And after altering the design, their junction temperature actually sank about 25 degrees Celsius, which is a pretty big deal. And it eliminated a lot of the failures due to those high temperatures. So we were able to go back into the FMEDA and look at what failures were due to overheating, especially those dangerous failures due to overheating, and reduce a lot of those. So although the engineers knew adding parts was going to be costly and redesigning it was going to take time and cost, they decided it was worth it to bring to the market a more reliable product. Thus, they brought a product with lower failure rates. Another example, and this could be on any type of device, O-rings. So we know that O-rings can do a lot of funny things. They can leak, they can stick, they can bind, they can break. But we have seen specially designed O-rings that were proven in testing to have less binding or sticking than average O-rings. So after we looked at the study and we looked at all of the test results, we went into the FMEDAs that were being used or these O-rings were being used in certain devices, and we could lower all of the failure rates due to sticking or binding associated with the O-rings. The great part, once again, those were some of those dangerous failure rates for this device. Next device we are looking at, a liquid level float. So in this design, their pivot had much less stress than usual. We looked at their calculations, they did an FEA, and we actually saw that, yes, it was seeing a lot less stress than normal. And because of that, we, because of their composition of material versus the stress that they were applying, we could lower the failure rates for that pivot and have a much lower failure rate for that individual component. Another example, we've seen solenoids. Everybody knows there can be some issues with residual magnetism. We've seen companies that have changed out their material composition to account for that. Once again, they've done their calculations, they've done their testing, and they could prove to us how much residual magnetism was cut out. Once again, we went into that FMEDA and pulled out all of the residual well, not all of it, but as much as the residual magnetism that they could prove they reduced in their design. Once again, that was leading to those dangerous failure rates. Another example, this was actually in a solenoid, and we once again did our typical FMEDA. When we did that, we looked at the device. It had both spacers and seals over the spool of the solenoid. They came back and said, well, I don't think we should be including the both spacers and the seals. And we said, no, that has to be included. We came up with a solution, a testing, a fault injection test. What we did was have them remove all those O-rings, then operate the solenoid. And it proved that there was not enough leakage to cause an actuator issue. And we were able to lower the failure rates of those O-rings due to leakage in the seals. Once again, this lowered failure rates for them, and especially their external leaks, which in this case they were very concerned about. So I want you to sit back and ask yourself, do you engineer above and beyond? Have you done things in your products and your devices that are that better, faster, stronger way of doing it? Is your device better than those around you? Are you already doing some of these things we're talking about and just not getting credit for it? Well, tell us what you're doing. Let us know all of your hard work and take credit for it. Not only take credit for it, but show your customers why you're doing all of this. I know all of this testing, all of this extra engineering comes at a cost to you that sometimes is hard to show your customers. But in the end, if you have a lower failure rate because of this, that could be the difference in proving to your customer all of the hard work that you've done. Of course, I did not take time to take any questions throughout the webinar, so I will take time now. And if you think of any questions later, please feel free to email me. Once again, there's some links to our blogs and our webinars, our books and our white papers. Always check back on those. We always have some great information. And also check out the website for our trainings. We have now online courses, or you can still come to a person in real life. If you love functional safety and want more, we could definitely help you out with that. There are no questions this afternoon. It was a quiet bunch. If you think of any later, please let me know. Thank you so much for attending this afternoon, and I hope you have a great evening.